Hello, my name is Alex Healing. I lead the Future Cyber Defense team in BT Applied Research. I'm going to speak to you a little bit about AI-enabled cyber defense. Do please reach out using the Engage tab. I'm looking forward to speaking to you. So just to set the scene, I know I'm going to talk a lot about how AI is used to defend the network against attacks, but I think it's worth just noting that attacks themselves, of course, are evolving all the time. And actually, AI is going to be increasingly used against us as individuals and organizations. So it's an arms race, essentially. And in terms of cybersecurity, there are three main types of activity. The prevention, you'll probably have heard of technologies like firewalls. There's the detection piece, and that's what I'm going to focus on in our work today, but also the response piece. We've got an active research program looking at how we can use AI to also automatically respond to threats once they're detected. But for now, I'm going to focus on detection, and that largely revolves around the data we have. Network telemetry most of the time. So very large scale logs like the one flying across the screen now, describing flows of information on the network. And the challenge is understanding the telemetry, describing the traffic going over the network, and understanding if there are behaviors there which could signify an attack of some sort, some malicious activity that we need to detect, we need to do something about. Now, going back a few years, there was a project in the team where we developed a tool called SATUR to basically make that data, those very large scale logs coming from a lot of different devices across the network for an enterprise, and make those a lot more accessible and give the power to analysts to explore those data sets in a very visual manner, being able to drill in on areas of interest in order to make the patterns within the data much more visual so that they could be easily spotted and understood. So the example on the screen there is, again, looking at flows of network traffic and then understanding geographical, the temporal aspects of those, and also the topological aspects. So which machines are communicating with other machines and looking out for suspicious behaviors in that respect. And so visualization is very important. And this was very much going beyond simple dashboards, very much creating a tool set for analysts to work with in a much more richer way, much more interactive way, where they had access to potentially petabytes of data. And so making that more manageable was very important. So at the sort of volumes of data we're talking about when looking at network flows and understanding the behaviors there, we're in the sort of order of several millions of events a second. And so if you try to visualize that raw data, you get very quickly what's been called a radiculogram. And that, it might be a pretty result, it might be an interesting result in some way, but not necessarily the best way of getting the insight you need from your data in the most efficient manner. And so the question that we've been addressing for the last 10 years or so is, how can we use AI to help unravel the complexity within the data and bring the most important aspects of that data, in this case, the telemetry, to the analysts, to the people that can understand and do something about it. What we have on the right here is an unsupervised machine learning technique, clustering. It's a visual clustering method that we developed. And this allows the analyst a means to understand the data in a different way. It structures the data in a particular way. It brings different events that have happened on the network together into these visual groupings. And then from there, the analyst can start to explore what do those clusters, what do those groups of dots on the screen actually mean by using lots of other views in conjunction and understanding the detail of why that is and whether or not it's significant for their investigation. So what we're really trying to do in our work in future cyber defense is going beyond simply having systems that alert people, alert analysts to a problem, but sort of go beyond that and provide technology to allow them to facilitate more of an in-depth analysis and investigation into actually, out of those alerts, which are the most important and what do I need to do about them. A lot of the motivation here, of course, is improving efficiency, operational efficiency for security operations. So I'm going to give you a few examples. One where we're focusing on the machine learning itself, the threat classification models and the anomaly detection, and also show you a new tool which we've called Nexus, which is about how do we provide a means for the analyst to really get into that data and explore it and understand the results of those machine learning systems. So Nexus is all about graph analytics. It's all about building a visual graph which depicts the relationships that may exist within your data. And that can be both the raw data, but also, more importantly, the results from any machine learning detection that we have going on. The example on the screen there is the result of some anomaly detection that we've run on network flows, where actually just from the behaviors of those network behaviors, it's pulled out various hosts on the network, so devices which are behaving a certain way, which is suspicious at a particular time. And then viewing it as a graph, you can see there's a high degree of commonality or correlation between those different devices. And that was for a good reason. In that case, that was that they were all beaconing out to the same command and control server. Other examples around things like port scanning, low rate denial of service attacks, or a botnet, as I mentioned already. There's a specific example as well. We've recently deployed a machine learning classifier, and that is to find what's called domain generation algorithms, or algorithmically generated domain names from DNS logs. So if you look on the top left table, obviously the first column there represents domains which we're familiar with, but a lot of malware which can infect networks and systems beacons out on these very strange looking domain names. So if we can devise a classifier to look for evidence of these sorts of domain names, which look very odd, they're not usual sort of human generated domains, then we've got a pretty good indicator that there may be a problem that we need to investigate. And so we built a classifier using training data of what these sorts of domains look like. Those are 3 different types of or families of malware. Essentially then the next stage is analyzing those results, having operational analysts look in at what the visual result is of those machine learning techniques. Obviously, the very high confidence results can be acted on immediately, but for those maybe less confident results, it needs that human in the loop to validate and to triage which of the results are the most important to gain insight from and act on. This is another example using the Nexus tool, and this was a few years ago when WannaCry and NotPetya, the very famous ransomware attacks, were at large. And this is actually a completely different type of data. This is financial transactions. This is a visual graph representation of the blockchain behind Bitcoin. And this shows actually the ransomware payments being made into those. Now, at the time, this was significant because we used the same techniques with some machine learning to identify similar behaviors across these financial transactions. We actually used that insight as part of a live investigation to track down essentially where there were instances of malicious software being sold on the dark web. And we could actually cross-correlate across several of those to attribute who was the original developer behind that malicious software, which was affecting our customers at the time. So a very significant investigation, a good example where it was a combination of machine learning, finding similar patterns within the data, but ultimately the visualization and the analysis by people to validate that and get the insight they needed. Just wanted to leave you on this note, which is that probably quite relevant given the last year of lockdown. We are also developing virtual reality or extended reality tools to bring all of these AI-based tools together in a virtual environment. Again, seamless integration between people and the machine collaborating together to get to a result within the data, but of course also facilitating people-to-people collaboration as well. So a virtual operations center of different tools where of course you can combine traditional 2-dimensional tools with much more elaborate 3-dimensional tools, for example, to analyze that data in different ways. So I thank you for your attention. I'll leave you with this quote, which I think sums up the philosophy quite well, which I rather like. And I invite any questions. I absolutely am very interested in your thoughts. So thank you.